Hello everyone, this is another video from Miss Semino. This is just kind of hopefully to be a quick and short video that will help answer these two questions. How do I name this and how do I write the formula for this? So the three types of substances that we're going to talk about are ionic compounds, molecular compounds, these are ones that have covalent bonds, and then how to write formulas for acids and how to name them as well. So for the first two substances that we have here, I have calcium chloride. And notice there's no polyatomic ion. And if you're like, what's a polyatomic ion? Remember SO4, PO4, ammonia here. These are all polyatomic ions. So if you just have two elements, and sometimes this is referred to as a binary compound, you would simply write out the first element's name, so calcium. And then instead of saying chlorine here, I'm going to call it chloride. You remove the ending and add the suffix "ide" here. This one over here, with our potassium and our oxygen, this would be called potassium. Now not oxygen, but oxide. Again, you can see the suffix of "ide" has been added there. Now down here we do have two ones with polyatomic ions. So similarly, I'm just going to write out calcium. So we're not changing the first element's name. So calcium, and then this polyatomic ion name is sulfate. So we don't do anything to that. We're just going to call it calcium sulfate. Then over here, this is, as I mentioned, this is our ammonium, and so this is our phosphate ion. So I hope I have enough room for this, but it's ammonium. I don't change that first name at all, and actually I don't change the second one here because it's already been changed because it's phosphate. It's a polyatomic ion. So that's how you name ionic compounds. Now, writing ionic compounds actually is much trickier than just naming them. So what we have to do is we need to balance, okay, the charges on these. And so just a couple of examples is if I have aluminum. Aluminum has a 3+ charge. Bromine has a 1- charge. So I'm going to need 3 bromines, okay, to balance out the charge in the 1 aluminum that I have. So the total charge here is 3+, total charge here 3-. So if you were to kind of add them up a little numerically, they would equal 0, and that's what we need. And the chemical formula for this is going to be AlBr3. Another way that we had talked about on another video and in class is this idea of doing this crisscross rule. So let me show you the crisscross rule really quickly. Okay, for the crisscross example here, we're going to use barium and nitride. And barium has a 2+ charge and nitride has a 3- charge. So I can go about this whole deal that I went through up here to balance out the charges by using 6 as the lowest common denominator. But an easier way is to kind of just write Ba, and then there's 3 here I'm going to bring down, make 3 bariums, and then N, then take this 2 and write the 2 here. So our formula here is barium nitride. So when you name molecular compounds, remember these are compounds that have covalent bonds in them, you really just need to just read the name there and then add the "ide" suffix and the prefixes along the way. So starting off with this first one here, carbon, it's going to be carbon. And then there's 2 oxygens, so it's going to be dioxide. So we didn't put a prefix because there's only 1 carbon for the first element, and we left the name the same. Then since there was 2 oxygens, we used the prefix di. We have the root here, ox, and then ide is the suffix that we add. So notice the second one. This one is going to be, take a guess. It's going to be carbon, di, because there's 2 of them, sulfide. Again, di and sulfide. So notice we keep the root here in the middle, but then these are the same. Now this next one, it's just going to be sulfur. Now it's going to be hexa, because that means 6, and it's on your periodic table, chloride. And this last one, notice that we have 2 silicons here, so it's going to be disilicon, hexa, I'm kind of running out of room, bromide. So notice that we only use a prefix on the first element if it's more than 1. And then we will always want to make sure that we use a prefix for the second element. So for example, I'm just going to write this one in the middle. If we had NO, it would be nitrogen. And we need to say monoxide, meaning 1. So even if there's only one of the second element, we still need to include the prefix for it. Now, writing molecular compounds, or the formulas for them, is so much easier than writing them for ionic ones. In molecular compounds, we don't have to worry about balancing the equations anymore. Okay, so the examples we have here, the first one is phosphorus pentachloride. So again, I'm just going to write the P for phosphorus, and then it's chlorine, but we have the suffix "ide" here, so chloride, and penta means 5. So the formula for this first one is going to be PCl5. Now if we look at the second one here, notice now we have a prefix here on the nitrogen, so it's going to be N2, meaning that there's 2 nitrogens, and then trioxide, so I'll have 3 oxygens, oxygen 3. And this last one is oxygen difluoride. So again, just 1 oxygen, write my F, and then 2 because of the prefix di here. Now when you write the formulas for acids, you do it just the same way that you would for writing ionic compounds. The charges have to cancel. So we're always going to know it's an acid because it's got this H out here in front, and the charge on hydrogen is always going to be 1+. Well, at least for acids for right now. And then let's go ahead and look at this first one. So the charge on bromine is 1-. Well, that's nice. The charges go ahead and cancel out here. So my formula for this acid is going to be HBr. Now, if we look down here at our second example, we already said our hydrogen is 1+, and our charge on nitrate here is also 1-. So now notice that these balance out, so 1+, 1-. So my formula is going to be HNO3. There's the formula for that acid. Now this last one is where it starts to get a little tricky. Again, hydrogen has a 1+ charge, okay, and phosphorus has a 3- charge. So I'm actually going to need 3 hydrogens to cancel out the charge in my 1 phosphite ion here. And so the way that I would write this formula, it would be H3 PO3. So you need to make sure that you are balancing the charges just like you would on an ionic compound formula. Now for naming acids, I just want to go ahead and let's just use the same 3 acids that we used on the last slide. And so for this first one, you're going to take we only have the 1 anion here, okay, so it's not a polyatomic ion, it's just an individual element. So the way that we write this one, it's going to look like this. When you only have the single element as your anion, your general convention is going to say a hydro with your root, ic, and then add the word acid. So for this one, we would call it hydro, brome, ic, then acid. So that's the name for our first example here. Now for this next one, I'm hoping that you know that this is nitrate, so this is a polyatomic ion. So now we're not going to use the prefix of hydro anymore. We're just going to call it, we're going to call it nitric acid. Okay. And the reason that I'm using the ic ending here is you also have nitrite, okay, which is NO2, also 1-, but this ends in an ITE. So notice we ended in ATE here, so we're going to use the ic. So 8 and ic go together. Then let's look in this last one down here. We've got phosphite. Now this one ends in an ITE. So we're not going to use ic as our suffix here. We need to use OUS. So the way that this one is going to be, it's going to be phos for us. Now this is our suffix. That's an S, by the way. Acid. Now there's a couple of other exceptions that we might see along the way is if I had a hypo, something with a hypo prefix, but look at your naming chart for that as well as perchloric. Well, I hope this video was helpful at reviewing how to name acids. Like I said a second ago, please check out your naming flow chart if we've written it down. If not, it probably should still be up on the board in class. Make sure you take a picture of it. Use that flow chart to help you write and name formulas. Good luck!